recording? Let's catch up. We're looking at the 5-1 practice worksheet. We're looking at questions 4, 5, and 6. So we're looking at question 4 right now. Okay, in the 5-1, we've gone ahead and graphed it. And we're looking for the median CK, right, as the median, which means we have to find point K. How can I use coordinate geometry? And when I say coordinate geometry, I mean things like the distance formula, the slope formula, the midpoint formula. All those things that we did a while ago. Which one of those formulas can I use to find point K?
Midpoint formula.
The midpoint formula, right. K is the midpoint of which segment? Which 2 points am I using to find the midpoint of AB? That's what I want you to do. I want everybody to show that work. If I ever ask you to do that on a quiz or a test, Maddie, you should be doing that work, right? So you should be finding, and I want you to write it on your worksheet. You don't need your pen open for the drawing board right now. You're just going to write it right on here. That's all I'm looking for you. Write the midpoint of AB. That's what we're going to do. Do you remember what the midpoint is? Jonathan can look it up because I think it's back there still, right? What do? Remember? All right, adding or subtracting? Adding, okay? We're adding the x's divided by 2, we're adding the y's divided by 2. So I'm going to literally go ahead and look at the x's and the y's. I'm going to add them and divide by 2. Oh, I used C. That was the wrong point. Sorry about that, y'all. You said AB, right? AB. There we go. So we're going to take 2 plus 12 divided by 2. And 5 plus negative 1 divided by 2. So I get 14 over 2 and 4 over 2. 4, 7, 2. Now I saw when I walked around, I saw that Reese had that answer already. Anybody else had that answer besides Reese? Mira? Okay, Milan? Good. Good job. Just the answer. Did you use the midpoint formula or did you just count?
Midpoint formula.
You did the midpoint formula? Anybody just try to count it? The distance formula is only going to give you the length. It's not going to give you the coordinates. Right? It's a good thought. We're looking for the actual points. Okay? Good thought. All right. I thought maybe someone would have tried to count. Nobody did that? Good job. I'm glad you did, because that's not as exact, right? We want to be as exact as possible. All right, so that's for number 4. Number 5 is a different question. Let's read number 5. What does number 5 say? What's the key word? Perpendicular bisector. If I were you, I'd be highlighting those words. And maybe even draw point K on my dry erase board. I might go ahead and plot point K on there so I know where it is, just like I have there. Okay? So you just have A, B, C, and point K on there. So put point K on your board. Okay, good. Put point K on your board. Just like I have it on mine. Make sure you're labeled A, B, C. Put point K on there. Okay? Good. Only point K. I don't want you to draw in the median right now. I'm going to go ahead and erase my median. We don't need it right now. I just want point K. How is point K going to help me answer question? So let's read the question again. We underline the word perpendicular bisector, right? What does point K have to do with anything of that? What does point K do to side AB? It bisects it. So we know point K has something to do with it. Since it says perpendicular bisector, now I'm just going to kind of guesstimate the drawing. I don't want you to ever do this, but you can get the idea here. Can you kind of visualize if it looks something like that? It looks like it's perpendicular to AB, but it goes through point K, right? That would be a perpendicular bisector. We're looking for the slope of that line. How do I find it? Good. I first find the slope of AB. Awesome. So let's do that first. Let's find the slope of AB. Good. So the slope of AB is going to, I should use capital letters, sorry. The slope of AB is what? How do I find it?
Don't formula.
The formula's fine. I can do count, rise over run. Either or is okay. The slope formula is what I would prefer as well. And that's going to be subtract your y's, subtract your x's. F minus a negative 1 over 2 minus 12. So that is 6 over negative 10, which reduces to 3 over negative 5. Did you get that? So that's the slope of AB. That's not the slope I want. What's the slope of the perpendicular? Positive 5 over 3. Excellent. Okay? So make sure you're adding that information, not drawing flowers. We're adding that information to the sheet we've asked you to do. Okay? And this stuff is on our test. Okay? Your test is Friday. I'm sorry, Thursday. Thursday. We still have one more question to answer. And that's the last one. Question 6. Do you see any keywords to question 6? Altitude. What does altitude do? It's from one of the vertices, and what does it do to the other side? Makes a right angle. It's perpendicular. Which vertex am I using? Which point is the altitude start at? If you look at number 6. Which point is on there? A, B, or C? What does it say? Point N on BC. We want an altitude that is NA. So which point am I going to start with? A. Okay? So NA. So we're going to find where point N is. Would you agree? Should we estimate it on our graph? Go ahead and try that. Where is a priceless fraction? I'll let it figure out. Where is 8 over 5 approximately? Is it close to 2? Is it close to 1? Is it close to 3? 8 divided by 5. 1.67. Okay, so 1 2/3. So go ahead and estimate 1 2/3. And if I go up 21 over 5, 21 over 5 is a little bit more than 4, right? So we're going to go ahead and estimate. Go ahead and draw point N. So about 1 2/3 and a little over 4. So here is my point N. And what does he draw it? It should be on our segment. Okay? So, it says, is NA an altitude of point ABC? What do you think? Yes or no? How would I check? Well, if I drew the line, which is fine, I'll just kind of throw it in. How do I know if that's an altitude? What do I need to do?
You need to find the slope and see if it's perpendicular to the line BC.
So I want this line here to be perpendicular to this line here. Would you agree with that? If they're perpendiculars, isn't that an altitude? So let's find those two slopes. Go ahead and do that. Find the slope of NA. Find the slope of BC. Which one is easier to find?
Try this.
Isn't N like a bunch of fractions? Okay, so let's try BC first, and then we'll look at NA. NA is not as bad as you think, actually. Let's try BC. Let's find the slope of BC. So what do we have? 8 minus a negative 1, and negative 6 minus 12. 9 over negative 18, or negative 1/2. Get that? Oh my God. Now, NA. Point N had the what was it, 8/5? 8/5, and then 21/5?
Yes.
Okay. So I got to use N and A now to find its slope. So it's going to take a little bit more work with fractions. Let's just write it down. I want everyone should write it down. You should be able to do fractions.
You can
So I'm going to do it my way. You can see what you want. So we'll see if that works. So we're subtracting our watts. 21 over 5 minus 5 over 5. Oh, sorry, not 5 over 5.
10 over 5.
Right, 25 minus 5. We'll change it in a minute. And then I have 8 over 5 minus 2. Do you agree with that? We're subtracting our x's and subtracting our y's. That's all I'm doing. What Marvin is suggesting, in order to subtract those things, we have to get a common denominator. I know you know how to subtract fractions because you've done it in 3rd, 4th, and 5th grade. I know that because my kids all went through 3rd, 4th, and 5th grade. I know because I helped them with their homework. Now, granted, it's been a while, right? So let's see if we can remember. I need to make 5 as something over 5. So what over 5 is 5? I wanted to convert this to a fraction. 25 over 5, okay? And if I want to convert a 2 to have a common denominator of 5, 10 over 5. Right? So we're just getting things where they have common denominators. That means I can subtract them. What is 21 minus 25? Negative 4 over 5. I thought it was negative 4.
No, because 21 is
Keep the same denominator. Well, I'll show you what it is. It does reduce that in a minute. Okay? And then I have 8 minus 10, which is negative 2 over 5. Now, since they're both over 5, we can just say negative 4 over negative 2, or we can just say positive 2. Okay? Now, what am I comparing? I'm comparing the slope of NA to the slope of BC. Are they perpendicular? Did I want them to be perpendicular? Is it an altitude?
you still know even though
It's an altitude, because they are perpendicular. Okay? So it's really all the work that I agree the numbers were messy, but it was just as methodical as we've always done.
So what about if the point they gave you is not on the line?
That still doesn't matter if it's on the line, because it's still going to be, the slope doesn't matter if it's on the line or not. Right? And on the line of the triangle, is that what you meant?
Yeah.
It's still going to be an altitude because it's past it. Okay, so it's from a vertex, right? Okay, good question, though. All right. Does that help a little bit going through those last 3 problems? I knew that coming in you were going to struggle with them. Okay? All right. What I'd like us to do is I will check for this homework assignment. Actually, I'd like to kind of collect it so I can check you off if I could. Try to check you off today. Actually, maybe I'll just try to come around and do it. Maybe it'll be a little bit easier. So leave it out so I can check it off. But I want you to copy down a couple of theorems on here, and I'll check for homework while you're doing that. But in your triangle flip book, we need to add both of these theorems under the angle bisector. So under angle bisector, you're going to write both of those. Okay? Now, is it important to write everything? I just wrote the if-then statement and then the diagram. Okay? So maybe I'll highlight what's important. Would that be easier to see? So we can kind of summarize here. So I wrote this, and then I wrote that. Okay? So that's what I want you to copy underneath the angle bisector, right on the pink sheet. Okay? So you're going to flip up the angle bisector and copy those down. And I'll come around and check the homework while you're doing it. So we have 2 theorems here that deal specifically with angle bisectors. And I think the first one is kind of almost a duh question, I think. I think it just kind of naturally makes sense. If I have an angle bisector, and I'm just going to highlight the angle bisector here. So SQ or QS is the angle bisector. And if that's perpendicular to each of the 2 sides of the angle, then I know that the length SP and the length SR is equal. And that kind of makes sense. Actually, we should know, it's not an official theorem yet, but the shortest distance between a point and a line is a perpendicular. So from point S to line QP is that perpendicular. That length there is the same as the length on the other side. Okay? The second one is one that we'll be looking at a little bit more and examining it a little bit more closely. And what I'm about to tell you for the next 3 theorems we're going to do have a lot to do with your MYP Okay, remember your NYP project is due when? Thursday. Hopefully you've been working on it. The concurrency of the angle bisectors theorem. Okay, what is that saying? What is the name of this point, point P right here? Those are all angle bisectors that connect at point B. If you look here, you should have that name written here. Do you? Do you know what that name is? What is that name? It's the in-center, okay? So I know that point P is an in-center. The reason I'm saying that is because maybe on your test, I will say point P is an in-center. You'll need to say in-center means angle bisectors. Okay, I know what I'm dealing with, okay? So point P is an in-center. What it says is that if it's an in-center, then the distance from there perpendicular to each of those sides is the same. That maybe is one of the things that you're going to have to discover on your investigative test, or your NYP project. Is there something where you're constructing two angle bisectors? I believe there is. Okay, so double check that. But you should be noting that those segments are the same length. So let's look at an example. Okay? You need to copy it down, Emma, will you not finish? Okay, go ahead and finish copying it. We have to look at an example. So the first thing you have to recognize in the picture is what am I dealing with? Okay? So I'm telling you ahead of time it's an in-center. Okay, so if we look at this next example, if you need to add this to your notes at home, it'll be online too. Okay? So you can always look at it there if you need to add it later. Or if we have time at the end of class, I can bring it up too. So I want to make sure we get through the examples. What tells me that point G is an in-center? What in the picture shows that? Let me make the picture a little bigger, because that way you can see it in the back of the class. So let's make this guy real big. Off kilter, but we can see it anyway. What tells me that this point is an in-center? What markings on the picture tell me that? The angle bisector marks. These marks right here. Would you agree? Okay. Now, obviously, I have skewed the picture, making it larger. Do you agree? It's not perfectly looking. What can I tell? If I know that GE, so I'm going to highlight GE is this distance here, is 2x minus 7, and GF, which is this distance here, is x plus 4. What do I know about those two distances? According to the last theorem we just did. They're equal. So what would the equation be that I would use to solve this? Equals x plus 4. Exactly. When I have angle bisectors, the segments to the perpendicular to the sides are all the same. Okay? And then it's a matter of just solving. So x is 11. Would you agree with that? To find the length of GD, what do? I want to find the length of GD. What's GD? How do I find the length of GD? Suggestions? If I plug 11 into 11 plus 4, what is the length of GF? 15. So GF is 15. What is the length of GE? It has to be 15. Therefore, what's the length of GE? 15. Doesn't matter. Which one I plug it into, they should all be the same. Okay? So angle bisectors, the big thing for the point of concurrency, from the point of concurrency, which is the in-center, to the perpendicular to the side, they're all the same. Here is the theorem for medians. So to pick up medians, there's only one of those. This is a pretty important one. So this is the example at the bottom, so don't worry about the example at the bottom. But go ahead and look at copy that theorem. So flip up the medians one and write that whole thing right up top. But really, from this picture, by the way, what is point C? It's the intersection, the point of concurrency of the medians, which is going to be the centroid. Okay? So we know that C is a centroid. If you want to write that down again, you can. If you kind of saying those names over and over, that helps you. What in the picture tells us that we have medians? What marks? The congruent marks, right. So these two congruent marks. These two congruent marks. All of those tell me that we're talking about medians. Okay? So point C is in fact a centroid. It's a point of concurrency for medians. So let's look at something. I know if I'm looking at DC and DJ. So from DC to DJ, one of those lengths is twice as long as the other. 2/3 versus 1/3. One's twice as long as the other one. We can do the same thing with EC and EG. EC and EG. One's twice as long as the other. 2/3, 1/3. Okay? And that's really what it's saying. And hopefully in your MYP project, the measurement, aren't you asked to measure some things? I think you're asked to draw, I think this is part 3, I believe, where you're asked to draw in the medians using a ruler, right? So we're drawing in those medians, and what are we looking for? This relationship, hopefully. Okay? So let's use this as an example down here. So we have a centroid, okay? We have a point of concurrency for the medians, and I'm told that this length XA is 8. Okay? So from the vertex to the stretch in the middle is 8. What's the length of XB? I want it to be the whole thing this time. How do I find, very well, let's try that again. I want to find the whole length XB. If I know this part is 8, what is it's twice as long as the other part, what does the other part have to be? 4. Because if this is 8, doesn't that have to be 4? One's twice as long as the other. So what's the length of XB going to be then? 12. It's that easy. 2/3 is twice as 1/3. Twice as long. Because 8 is twice as long as 4. 2/3 and 1/3. Okay? So I'm going to try to explain here. So this length here is 2/3 as long as this length here. One's twice as long as the other. 2/3 and 1/3. 8 is 2/3 of 12. 4 is 1/3 of 12. I'm going to think about it that way. Okay? Want to try another one? Get a little feel for it? Let me give you a different example. Same picture. What if I said that the length of, we have this answer as well. What if I said that AC is 3? What is the length of AC? One of them is shorter than the other. Which one is shorter? Is AC shorter? So this one is shorter than the other one. Would you agree with that? So the 3 is the shorter one, Shay? In this case, one has to be twice as long as the other. Okay. So what's the length of AZ? 6. It's just twice as long. That's it. AC is 6. Done. Could you tell me the length of the whole thing? CZ? 9. It's added together. We okay with that? 2/3, 1/3. That's all. Alright, so some things are equal, some things are twice as big. The last, we have one more. Let's try it. Oh, that's one I've already done. Sorry. Here's the last one. It's got quite a bit on it. I think you can skip the first one writing it down. We can at least talk to you about it. I think the last two are more important. So if I have a perpendicular segment, okay, a perpendicular bisector, so just look here. Don't write this one down. So we're not going to write this one down, okay? But if I have a perpendicular bisector, and I have some point P on it, the distance from P to the endpoint is going to be the same as well. That's all. Don't we already know that? If it's a bisector and an altitude, isn't it an isosceles triangle? Don't we know that already, really? So we're going to skip that one then. Okay? But what I do want you to write is these last two. They need to go both underneath the perpendicular bisector. So that's the top left, I believe, right? So right under here, you're going to write both of those things. Okay? can be on the inside of a triangle, on the triangle itself, or on the outside of a triangle. And in your MYP project on part 2, where you're actually cutting them out and folding them to create the perpendicular bisectors, you're going to be showing me that. And you're going to glue those down on a piece of paper, right? So that's what I'm asking you to do for that one. But what does the theorem tell us? The theorem says that from the point of concurrency to each of the vertices, so PA, PB, and PC, when we're talking about a circumcenter, those distances are all the same. Okay? So we don't have a 2/3, 1/3 thing, or one's twice as long as the other. We just So anyway, all of those distances are the same. So let's look at an example where that could happen. Okay? So here's one where I'd like for you to try it. So if you would, go ahead and get it up. If you have graph paper, that's wonderful. If not, I would like for you to put it in your notes somewhere. Okay? Or you can do a sketch if you need to of graph paper. But we should have some. Turn the lights up a little bit so you can see. But I would like us to actually try this. And that's because a problem like this will be on your test as well. Okay? So if you have graph paper, let's use it. Let's be exact. Put it in our notes. I'm asking that you go ahead and graph points P, O, and S. P is the point 0, 6. O is 0, 0, and S is 4, 0. So I'm going to graph the point 0, 6. Label that point P. We have 0 is 0, 0 is the point O, and S is the point 4. I'm just going to draw in the triangle. Darken it up a little bit so you can kind of see. That. And I have this triangle, OPS. Now, a couple of things. What is it asking us to find? You read the directions. It says to find what? What are the coordinates of what? Keyword. And we know what a circumcenter is. What's a circumcenter? Where the what intersect? Okay? These are perpendicular bisectors. Okay. So how do I find that? First of all, if the word was where the if I said a different question, if I said where the orthocenter is, what's the orthocenter? Altitude. Where do the altitudes in a right triangle intersect? Think about it. Which point? The altitudes intersect at point O. You agree? That's an altitude. That's an altitude. Where do they intersect? Point O. So if it had said orthocenter here, there'd be no work to do, would there? The work would be point O. I'm done. Because I have the orthocenter there. But that's not what it said. It said circumcenter. A little bit more work involved. So how am I going to find the perpendicular bisectors? Well, could I possibly bisect OS? I know I can just count, can't I? Where's the midpoint? 2, 0. So I know this is the midpoint. So couldn't I just draw bisector in there? It's a vertical line, right? Draw it in. That's the perpendicular bisector of OS. Drawn it in. I want to now find the perpendicular bisector of, easy one would be what? What would the easy perpendicular bisector be? OP. Let's count up and find its middle point. Where would it be? 0, 3. And let's draw in its bisector. So where do they intersect? At what point do they cross? Again, different than the orthocenter. The orthocenter was where? That's where the altitudes cross. That's the X00 in this case, correct? So keyword, making sure you know what the word means and where to find it. Okay? We'll guarantee have a problem like that on the test. Guaranteed. Are there any questions about how to do it? Now, let's get and it's going to be the midpoint. And if the right triangle, and you have a vertical and a horizontal, you're going to be the midpoint from the line. Just count the line. Any other questions? Again, if it's an orthocenter, you just a question. You should still be able to understand. All right. So, I'm going to change your homework. Actually, what I want is 30 minutes left in class. We're done everything. Check. I talked to you about what's on the test though, because it's a lot. Okay? And whatever you want to review, we'll review these last 30 minutes. Okay? So let's talk about what's on it. I might write test outline and write these things down if I were you, so I know what I can expect. Okay? By the way, what we just did with those theorems that we wrote, there's one problem on the entire test like it. It's not a major part of the test. Okay, just one little problem. That's it. So let me get an old version. The first objective, again, this is an old test, not your exact one. But your first objective is triangle, I'll just say angle. I can use the triangle angle sum theorem, exterior angle theorem, and properties of isosceles triangles. So how about if I just say interior, exterior angles, and isosceles triangles? Is that okay? It's going to be a lot like the first quiz. At the back of that first quiz. Do you know the exterior angle theorem? Like, for example, do you know that this angle is the sum of 40 plus 50? Remember that? That's those kind of things. So studying that first quiz, the back of it, I'll just write, back of the first quiz is a good thing to study. Okay? The second thing, second Roman numeral is segments in a triangle. That's like the back of the second quiz. Okay? Do you know the names? Do you know what a perpendicular bisector is, an altitude is, a median is? Do you know what an orthocenter is? Do you know all of that stuff? That's the back of quiz 2. It also is going to include some equations. So let me think about these here. Let's see what so it would be like problems page 10 on your packet. Everyone wants to look at page 10 for me. Where you had to write an equation. It says something is an altitude, solve for x. Something is a median, solve for x. Remember how we did that last class? Those kinds of questions. Okay? Mid-segments of all of them. And then the theorems that we did today. You know, one side is double the other, or they're the same length, or something like that. That's kind of a big segment, a big section. The third section is a triangle inequality. It's kind of like front of the second quiz. And then the back. Okay. Triangle inequality. Let's look at some. What angles across? Can you order the angles in order from smallest to largest? Can you order the sides from smallest to largest? What angle is across from the largest side? That kind of stuff. Can you give me a range of the third side? So for example, if I had a triangle where I had the possibilities for the other side. Remember how to do that? What's the answer? Between what and what? Between 7 and what's a 3 and a 4? So between 1 and 7, remember you add them as a factor, right? All the possibilities for that third side. Alright, so all of that stuff. Okay, triangle inequality. And that's the last section. Okay. So the last section is the construction section. We're going to need to be able to construct everything. So construct all 5 segments and inscribe an equilateral triangle. And I think that was it. So you have to be able to construct. An altitude. What is the point of concurrency for an altitude? You need to know these names, folks. Study them. Make flashcards to help. Okay? Orthocenter. So you need to be able to construct an altitude or any 2 altitudes intersecting an orthocenter. You have to be able to construct a perpendicular bisector. Or any 2 perpendicular bisectors intersecting what's called the circumcenter. You have to be able to construct a midsegment. There's no point of concurrency for a midsegment. You have to be able to construct a median. And centroid. Right? And then the last one is the angle bisector. And they intersect in the incenter. So you have to be able to do all of those. And then the last one we did was a inscribed equilateral triangle. Or inscribed or attempted triangle. An equilateral. And we did 2 sections here. So in my mind, there's a lot on this test. I wish we would have broken it up into 2. I think it's a lot of information. Right, Josh? Right? You late to class, are you sleeping in class? Come on, push hard. Come on, Miss Lester. Okay? So, 1, 2, 3. Lots of stuff. They're each about worth the same amount. Each of the sections. They're all about 20 points. Okay? The extra credit is going to be, I don't think there is any, oh, there is a 3 extra credit on the test. There's 3. Okay. What do you need to review? Good question. I don't know. Probably since we haven't done it in a while, I'll give focus. Okay? Yes. Which we did in class today? Yeah. Yeah. I think that there might be only have one like that. And it would be somewhere in the segment section. Okay? So yes. What do you want to practice? Let's start trying together. Tell me what you need to review. I don't remember how to construct a centroid. I don't remember how to do an equilateral triangle. Help me. Brittany. Are you sure? One question the whole test on. You guys have time on it? Okay, well, I mean, it's just using coordinate geometry. If it says median, use the midpoint formula. If it says perpendicular, use the slope formula. Nothing else is standard from there. Okay? Help me out, guys. What do you want to practice with? Your cohorts, instead of your MYP project, if you look at your packet, at the very end, you have a test review. Okay? And so I'm going to be looking for that for homework. So, maybe to help, the whole thing. Okay? So, it's a lot of problems. Okay? But it's the test review. I'll give you some time in class to start working on that now. But that test review will help you with what's on the test, okay? going to keep project pushed off to next